Welcome Math 107 students to the second day of rational functions, and we're going to be taking a look at the preview exercises for lesson 26. So in the last class we studied two new parent functions, f of x equals 1 divided by x, which we call the reciprocal function, and g of x equals 1 divided by x squared. We can graph a lot of rational functions just by performing some transformations to these parent functions. The transformations that we studied a few weeks ago, vertical and horizontal shifts to these functions, or shape changes, vertical and horizontal shape changes by stretching or compressing them. Remember also that the value of x that's excluded from the domain here, in this case x cannot be 0 for either one of these functions, became the vertical asymptote on the graph. So let's go ahead and just take a minute and take a pen or a different colored pencil and make a dotted line, vertical dotted line straight down through x equals 0. That's our vertical asymptote. All right, so now we've asked you to label each graph below with one of these equations. F of x equals 1 over x, and g of x equals 1 over x squared. Well, the reciprocal equation, what's true about reciprocals? If you put a positive value into the reciprocal function, a positive value comes out. So if we look at positive values for x, we see that both of these graphs have positive outputs. So that means right now it could be either this first graph or the second. However, if we look at a negative value, we know the reciprocal has the same sign. So for negative values of x, we have to be below the x-axis. So this is f of x equals 1 over x. And therefore, this one is g of x equals 1 over x squared. I also would just like you to briefly recall another idea we talked about a while back, and that has to do with even and odd symmetry. The reciprocal function has odd symmetry. And the reciprocal function 1 over x squared, the reciprocal function squared, has even symmetry. So this has symmetry about the y-axis, and this has symmetry about the origin. Okay. So that was just a little thing from our past I wanted to throw in there for you to recall. And I think you can remember, maybe you can remember that the test for even symmetry is if I put in opposite values for x, opposite values, let's just say opposite inputs create the same output value. Whoa, my pen went crazy on me. Output value. Same outputs. Whereas with the function that has odd symmetry or symmetry about the origin, opposite inputs produce opposite outputs. Output values. Okay. That's always a concept that takes 107 students a while to grasp. I think sometimes it's the notation, like this notation, and then the notation for odd symmetry looks like this. It takes a little while when you're getting used to functional notation, but this is sort of the wording and the graphs that go along with each of those ideas. All right, let's continue on. How do we find vertical asymptotes for any rational function? This should have a letter there like r of x. How about r for rational function? R of x is p of x divided by q of x, where both p and q are polynomials. And so we have seen so far that to find vertical asymptotes, we find when q of x is equal to 0. So the values of x that make the denominator 0 may lead to vertical asymptotes. And I'm saying may because sometimes there's a possibility that one of those values produces something else called a hole in the graph, but we'll save that for a little bit later in the demo. Okay? But there's always a possibility when you factor your denominator and you find the values of x that make the denominator 0, that there's a vertical asymptote at that point. Identify the equations of the vertical asymptotes in the graph below. Well, this graph has no vertical asymptote. There's no dotted vertical lines. This graph has a vertical, so this one has none. This one has a vertical asymptote at x equals 2. And this graph has two vertical asymptotes, one at x equals -2 and one at x equals +2. And as you can see here, I've got the equation here for g of x, and if we factor this denominator, lo and behold, there are two values for x that make that denominator 0, and we have two vertical asymptotes here. Okay, now, can a graph of a vertical asymptote, or excuse me, can the graph of a rational function intersect a vertical asymptote? No, never, 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 never. Because somehow, if it did, there would be a number that you would get when you divide by 0, and that's never going to happen. Division by 0 is undefined. Gets really close to that vertical line, infinitely close as a matter of fact, but never touches it, never crosses it. And how do we indicate a vertical asymptote on a graph? With a dotted vertical line, just like you see here in these two graphs with the pink vertical line. Okay, that's it for the preview exercises. If you have any questions, send me an email. I'll be glad to help you out.